This is the 7th grade math end of year review for 2015. The first one that we have is reducing ratios. Our first ratio is 51 to 9. We can tell using our divisibility rules that since 5 plus 1 equals 6, that it's divisible by 3, and 9 is divisible by 3, so we can divide both of those by 3. So we get 17. 51 divided by 3 is 17 to 3. So that's our first simplified ratio. Our next ratio that we have to simplify is 17.5 to 10.5. They are both divisible by 5 since they ended with 5s. So we divide by 5 first of all. 5 goes into 17 3 times with 2 left over. 5 goes into 25 5 times. Bring the decimal point up, 3.5. And divide this by 5. 5 goes into 10 twice. Decimal point goes up, and 5 goes into one time into itself. Then these are both divisible by 7. For our next one, we have 17.5 to 10.5. First of all, we can see they both end with a 5, so they're divisible by 5. We divide this by 5, it goes in there 3 times, and leaves 2 left over. 5 into 25 5 times, and of course our decimal point just moves straight up. Same with here, our decimal point is going to move straight up. 5 goes into 10 twice, and 5 into 5 one time. Now if we look at these, we can see they are both divisible by 7, so we can divide them by 7. Decimal point goes up. 7 goes into 35 5 times, and 7 into 21 3 times. So our ratio is going to be 5/10 to 3/10. Our next one that we have is another ratio problem. It says the ratio of boys to girls is 12 to 17. Ratios can also be written as a fraction. And it says boys to girls, so the top part is boys, and this is girls. And then they want to know if there are 85 girls. 85 will need to go down here on the bottom to match girls. How many boys are there? So boys is our variable that we don't know. When we have a proportion, which is 2 equal ratios, we can cross multiply. So we get 17 times x equals 12 times 85. So we're going to do 85 times 12, and 2 times 5 is 10, 2 times 8 is 16, 17, then 85 times 1 is 85, so we have 0, 12, and 10, 1020. Okay. So 17x just comes down, and then we're going to divide both sides by 17. So we have 1020 divided by 17. This can go in 6 times. 17 times 6. 6 times 7 is 42, carry a 4. 6 times 1 is 6. 7, 8, 9, 10. That's 102. Subtract and we get 0. Bring down the 0. And even though it's 0, we have 17 goes into 0 0 times. So therefore, for this one, x is going to equal 60. So there would be 60 boys in the class. Our next one says fill in the missing numbers in the geometric sequence. A geometric sequence is when you are multiplying to move to the next number, and you always multiply by the same number. Or if you are going the opposite direction, you would divide. So that's going to be a geometric sequence. Let's take a look at the first one. We have blank, then 6, then negative 36, and 216. And then blank. So for this, we can tell 6 times 6 is 36. And of course, to make it negative, we'd have to do negative 6. So therefore, if we check with that here, times negative 6, we're going to get 216. Then we take 216, multiply it times 6. 6 times 6 is 36, carry a 3. 6, 7, 8, 9, and 6 times 2 is 12. So this is 1296, and of course it's a negative 6, so we have a negative answer. Then to go backwards, we're going to divide by negative 6. So when we do 6 divided by negative 6, we're going to get negative 1. So that's going to be our answer for our first one. For our next one, we have blank, then 1/9, then 1/27, and then blank. So once again, we have to find out what we're going to multiply by. Since they're fractions, the easiest thing to do is go ahead and go backwards and do our division. So we're going to start with 1/27, and we're going to divide by 1/9. And here we keep this to 1/27. We change this to multiplication, and we flip 1/9 to 9/1. We can then cancel the 9 and the 27 to a 1 and a 3, and we get 1/3. So that means that our constant for this is going to end up being 1/3. So we divide it by 1/3. So in order to do this, we can check. 1/9 times 1/3 does equal 1/27. So then if we multiply here by 1/3, we're going to get 1/81. Now to go backwards, we're going to end up doing a division. And when we do a division, we're going to do 1/9 divided by 1/3. So we keep, change, flip. And we get 3/9, which equals 1/3. And of course, we can always cancel here to a 3 and a 1 and get our 1/3 also. For the next one, we have some angles that are being added together. We're given 3 of the angles, and we're trying to find out what B is going to be. What's important here to remember is that when you're adding up the measures of the angles on a straight line, altogether it will always equal 180 degrees. So we're going to add these 3 plus B to equals 180. So 45 plus 39 plus 24 plus B has to equal 180. So the first thing we're going to do is go ahead and combine like terms. So we're going to add 45, 39, and 24. And we get 9 and 9 is 18, carry our 1. So 3, 6, 10, 108. So 108, then bring down the plus B and the equals the 180. Then subtract 108 from both sides. And we get 0 here, cancels right out. So we have plus B, so a positive B equals, and then it's going to be 72. So B is going to be 72 degrees. Our next one shows a parallelogram, and it is divided by some diagonals. When we have diagonals here, they're going to be bisected by each other. So it says DS, so D is here, S is here, and that has a measure of 9 inches. So this is 9 inches. And the question is, what's the measure of DB? DB is going to be the whole length of this. Since this first one is 9 inches, the next one is 9 inches. So we'll add those to get 18 inches for our answer. For the next one, the first shape that we have is a cube. Next we have a triangular prism. The triangle's the base, and then we have the rectangles that are added to it. Then we're going to have a triangular pyramid. Once again, the base is a triangle, and then from the apex we have 3 lines going down. Then we're going to have a rectangular prism, and finally we're going to have a square pyramid. Once again, a square for the base, put in our apex, and fill in our lines to each vertex. Next, it says which of the following cannot be a triangle. So we have 6 inches, 7 inches, and 2 inches. For this, we have to remember if we take our 2 smallest numbers, so our 2 smallest numbers have to be greater than the largest number. So 6 plus 2 is greater than 7. So this one, first one, is a triangle. For the next one, it is 15 inches, 8 inches, and 6 inches. If our base is 15 inches and we try to take an 8-inch piece and a 6-inch piece, which only equal 14 inches, and if we tried to put them on top to form a triangle, we would have a 1-inch gap. So therefore, these 2 end pieces would not stand up, so that is not going to be a triangle. Our next one is 12, 5, and 7. So once again, a base of 12, 7 and 5 equals 12 exactly. So therefore, they would fall flat because it would be like having 2 rulers together. They're not going to be able to form a peak. For our next one, we have 3, 12, and 11. If this is 12, 11 could go all the way over here, and 3 would actually make it stand up. So, therefore, the last one is going to be a triangle. Next, it says to find C. They tell us that this is 60 degrees, this is 40 degrees. The interior angles of a triangle are 180. So 60 plus 40 plus C have to equal 180. So combine like terms, 100 plus C equals 180, and 100 plus 80. So C has to be 80 degrees. Our next one that we have shows a triangle. It has A, B, and C. B has a square. C is 52 degrees. There is a 12 here. And they want us to find B and A. B, since it has a square, is automatically going to be equal to 90 degrees. And then this 12 is the length of a side, so it has nothing to do with the angle. So we're going to ignore that. And we are going to once again add our 3 angles to equal 180 degrees. So 52 degrees plus the 90 degrees plus angle A has to equal 180 degrees. Combine our like terms. We have 142 degrees plus A equals the 180 degrees. And then we subtract 142 from both sides. This cancels right out. And we have A equals 38 degrees. For our next one, they give us a circle. They give us a radius of 6 centimeters. They want us to find the circumference. We use the formula C equals pi times D, or the diameter, which of course is all the way across the circle. So they tell us to use 22/7 for pi. So we can put in parentheses for our 2 different variables. We can put 22/7 in for pi, and for D, if halfway across the circle is 6, all the way across the circle would be 12. Make that into a fraction, and so then we simply have to multiply. 22 times 12, so 2 times 22 is 44, and 22, so that's going to be 264. over 7. So 264 over 7. You could go ahead and divide it to get a mixed number. Our next one says the map has a scale of 1 inch to 25 miles. So we have 1 inch to 25 miles, and they want to know what's the distance between two cities if the map shows a measure of 3.2 inches. Since 3.2 goes with inches, it's going to have to go on the top to match the inches, and what we want to know is the miles. That will go on the bottom. And so at this point, what we're simply going to do is cross multiply. So 1 times x equals 25 times 3.2. So that's going to be 1 times x is simply going to be x. And then to get your answer, you will simply need to do the multiplication. 25 times 3.2. For the next one, it says find the average of x, x minus 7, and x minus 2. So to find an average, we'll simply add up our 3 different terms, and then we divide by the number of terms, or 3 in this case. So for this, we're going to go ahead and take what we have here and take our x, and we're going to add x minus 7, and then we're going to add x minus 2. Now we're going to use the commutative property to put our 3 x's together, and our minus 7 and our minus 2. Use the associative property to put those together, and we get 3x, and backwards 7, backwards 2 means backwards 9. And we're going to divide that by 3 because there are 3 different terms that we started with. So we're going to divide each of the terms by 3. So we're going to have 3x divided by 3 minus 9 divided by 3. Once again, 3 over 3 is 1, so that becomes x. Bring down the minus sign. 9 divided by 3 is 3. So our average is going to be x minus 3. For the next one, they want us to find the median, the range, the interquartile range of both classes. Now once again, this is a box and whisker plot. You are going to have, for these, some boxes. Okay? Then you're going to have whiskers, which are going to come out on both sides. And then you're going to have a line in the middle. First of all, to find the median is this line right here. So just take a look where that touches on the number line, and that tells you what the median is. Okay? Then to do the range, you're going to take the largest number minus the smallest number. So large minus small equals the range. So that will go for both the top one, and then here find your largest number and then subtract the smallest number. So once again, large minus small. To do the interquartile range, what you're going to do, the interquartile range is going to be the ends of the boxes. So you're going to find where this hits, that's going to be your large number. Then where this one hits, that's your small number, and do large minus small. And that's going to be your interquartile range. So once again, the same thing will happen for this box and whisker. You're going to go down and find the large for this, and then take the other end of the box, go down, find the small for that, and then do large minus small. Then you have a problem finding the surface area of a rectangular solid. Tells you that this is 6 centimeters, this is 5 centimeters, this is 11 centimeters. So every line that goes this direction is going to be 11. Any one that goes this direction here is going to be 5, and any one that goes straight up and down is going to be 6. So this box is going to have 6 sides, a top, a bottom, a front, a back, and a left and a right. So we can go ahead and take a look at the top. The top goes right here. It goes a long way, so it's 11. And then it goes over here, so that matches the 5. So we do 11 times 5, or 55. So the top is 55, and that means the bottom is also 55. Then we can go over here to the right side, and we have, once again, it touches the 5 and the 6. So we're going to have 5 times 6 is 30, and if the right side is 30, since this is going to have a congruent side on the other side, that will be 30. And now we do the front. The front goes along this way, it touches the 11, it goes up. Going up means it goes with the 6, so that's going to be 66. So since the front is 66, the back is also going to be 66. To get your surface area, all you're going to Our next one asks us to use a Venn diagram. We make a box to have all the amount. We know the whole amount is 40 students. We know they're taking English Comp. There are 14 altogether going to be in that circle. And then there are 29 taking chemistry. So 29 will be in that circle. We know that there are 5 in both classes, so we want to know how many are in neither of the classes. So one of the things that we're going to know is, since this circle right here for the chemistry is 29, if 5 of them are in there, then this has to be 24 to equal our whole 29. So this is going to be 24. And then our other circle over here, if we just look at that circle, we know the whole circle is 14. We know 5 are in both, so that part of this circle right there is 5. So this would have to be 9. So that's going to be 9 right there. So when we take a look at these right here, we're going to see that we have several that are going to end up adding up together. So what we're going to do is go ahead and take everything that's in our circle here, which is 9 plus 5 plus 24. So we're only going to count the 5 once because it's the same students. So our 9 plus 5 is 14 plus 24, which is going to equal 38. So we know that altogether this has 38. We know 40 is the whole amount, so therefore 2 would be the ones that are in neither class. Next, we're going to go ahead and take a look at the probability. There is a spinner here. It is divided into 8 equal sections. We have A, B, C, and then E, F. On some of these it did not print well, so you may have thought that it was A, B, C, and then all of these were F's. So we'll do it for both ways. The first says, what's the probability for A? So the probability for A, probability once again, is always favorable, or what you want, over all, over the total. So A, we have 2 A's over 8 total, so that's 1 out of 4. And that's going to be the same for this one also, 1/4. Then it says, what's the probability of F? So if you did this one, the probability F, there are 1, 2, 3, 4 F's. So 4 out of 8 total, which would be 1 out of 2, or 1/2. If you did the probability for F on this side, you would have just 1 F out of a total of 8, so 1/8. Then the probability of a vowel. A vowel on this side right here, you would just see the 2 A's. So you would have 2 out of 8 total, which is 1/4. On this side here, probability of a vowel is going to be 1, 2, 3, 4, 5. So that will be 5 out of 8. So if you thought these were 3 E's and an F, A would be 1/4, F would be 1/8, and vowel would be 5/8. If you considered all these to be 5's, you would still have 1/4 for an A. You would have 1 to 2 for the F and 1 to 4 for the vowel. The last one on the front is the stem and leaf plot. I'm going to go ahead and quickly draw this. Your stem is 13, and then 14, 14, 15, 15, and 16. So then you have here 6, 9, 9. So this would be 136, 139, 139. Then here we have 2, 3, 3, 3, 3, 4. Then we have 6, 7, 7, 8, 9. For 15 we have 1, 3, 4, then 6, 7, and then 2, 4 to go with 16. So once again, this last number is 164, the 16 plus the 4. The first number is the 13 plus the 6, or 136. The first one asks how many elements there are. There's 136, 139, 139, so we simply count the numbers on this side right here of the stem and leaf plot, so just to the right of this line. So we have 3 on the first line, plus on this line right here, we're going to have 6. Here we have 5. Here we have 3, 2, and 2. So therefore, that's going to be 5. That would make 10, 19, 20, 21. So we have 21 total elements, first of all. Next thing they're going to ask is, what is going to be the median? So for the median of this, we want to find the middle number. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we're going to take 21, and if we have 21, that means we would have 10 on one side, 10 on the other side, and then the extra 1 would be right in the middle. So we need the 11th number. So we have 3 plus our 6 here is 9, 10, 11. So that means that is going to be our median. Once again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 below, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 above. So the median is going to be 147, because remember we have to count this 14 with the 7. So 147. Okay. Next, we're going to go ahead and take a look at the lower quartile. To find the lower quartile, what we're going to do is we're going to go ahead and we know this is the median right here. So the lower quartile means we're going to divide it into 4 quarters. So 1/2, the median is 2 quarters. 1/2 is 2 quarters. Then we have 1/4 of the way and 3/4 of the way. So the lower quartile is going to be 1/4 of the way. So we divided them in half, and then 1/4 is half of a half. So we're going to take these 10 and cut them in half. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we have 10 and we divide it in half, we're going to have 5 and 5. So therefore, these first 5 right here are going to all be below, and then the other 5 are going to be above. So the lower quartile is therefore going to have 5 in it. The last thing that we have is a table, and it shows for a number cube, the number on the cube, and the number of tosses. And of course, there are 6 numbers on the cube, and our probability for getting a 1 is 1 out of 6. Probability of getting a 2 would also be a 1 out of 6. A 3 would be 1 out of 6, and so on. So all of them should theoretically show up the same number of times. When we look at them, we find we have 18, 15, 20, 14, 22, and 11. So some of them, like 22, are high, or some like 11 are low. The reason they don't appear the same amount is because this is experimental probability, which is not always going to be the same as theoretical probability. Now, if these numbers were a lot higher, let's say they rolled it 1,000 times, they would become closer. But we know, for instance, the probability of getting heads or tails is 1 out of 2. But if you tossed a coin 5 times, you could have tails each time, where theoretically it should be about half and half.